Dear students, in last class I asked you to substitute the value of In equal to minus of I1 plus I2 plus and so on up to In minus 1 in equation 15 and get the expression for lambda 1p. I do not know how many of you have derived it or simplified it. Now I will tell you how to do that. Now in equation 15, in the second term here, in place of In you substitute for minus of I1 plus I2 plus and so on up to In minus 1. We will see here what happens now. Only I will show the simplification for second term. Two into 10 raised to minus 7 into the bracket I1 ln of d1p plus I2 ln of d2p plus and so on up to In. But what is the value of In now? In is equal to minus I1 plus I2 plus I3 plus and so on up to In minus 1 into ln of dnp. 2 into 10 raised to minus 7. If I open the bracket here, minus sign will go with all the currents. Then I will take each negative current with ln of dnp with respect to positive currents here. That is I1 ln of d1p minus I1 ln of dnp plus I2 ln d2p minus I2 ln dnp plus and so on up to In minus 1 ln dn minus 1p minus In minus 1 ln dnp. Now we have to make use of ln of a minus ln of b equal to ln of a by b. So right here using two into 10 raised to minus 7 into the bracket I1 into ln of d1p upon dnp plus I2 into ln of d2p by dnp plus and so on up to In minus 1 ln of dn minus 1 P upon dnp. So this is how we get the simplified second term, and this second term we have used in lambda 1p, that is here, right? Now we will take inductance of one phase two wire composite conductors line. Here we will consider a single phase system having two wires A and B. Each wire is having the multiple number of conductors in it. Let us assume two wires A and B consist of respectively M and N composite conductors. As shown in figure below. See, these are composite conductors in wire A, and these are composite conductors in wire B. If there are m number of conductors, then the current flowing through wire A will be divided into m paths, and if there are n number of conductors, then the current that is flowing through wire B will be divided into n paths. So right here, the current in each conductor of wire A will be I by M, where I is current flowing through wires A and B, and of wire B will be I by N. One group of conductors acts as a go conductors for single phase line, and the other as the return conductors. It simply means that the direction of current flowing through wire A and wire B are opposite to each other. In other words, if current through wire A is flowing into the base, then current in wire B will be flowing out of the base. The flux linkages of any conductor say 1, that means in wire A we are considering conductor 1. Will be lambda 1 equal to 2 into 10 raised to minus 7 I by m ln of 1 by d11 plus I by m ln of 1 by d12 plus and so on up to I by m into ln of 1 by d1m. This term gives us the inductance of conductor 1 because of the current flowing through itself and because of current flowing through other conductors in wire A. Now we have to write the second term which will give us the flux linkage, due to the current flowing through the various conductors, that is from A to N in wire B. So plus 2 into 10 raised to minus 7. Current flowing through wire B is minus I upon N because directions are opposite. Ln of the distance between conductor 1 in wire A and conductor A in wire B, that is 1 upon d1A minus I upon N ln of 1 upon d1B minus and so on up to minus I upon N ln of 1 upon d1N. Using laws of logarithm, we can simplify lambda 1 as 2 into 10 raised to minus 7 I into ln of nth root of d1A into d1B into and so on up to d1N by mth root of d11 into d12 into dash 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 up to d1M. The inductance of conductor 1 in wire A will be L1 equal to lambda 1 upon I upon M, because the current flowing through each conductor in wire A is I upon M equal to two M, because when I divide this by I by M, I and I will cancel and M in denominator here will go to the numerator. 2M into 10 raised to minus 7 ln of nth root of d1A into d1B into so on up to d1N by mth root of d11 into d12 into and so on up to d1M. Similarly, the inductance of conductor 2 in wire A will be L2 equal to lambda 2 upon I by m, that is equal to 2m into 10 raised to minus 7 ln of nth root of. Here you just replace 1 by 2, that is d2a into d2b into and so on up to d2n divided by mth root of d21 into d22 into d23 dash 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 up to d2m. Like this we can write up to the inductance of mth conductor. The average inductance of m conductors in wire A L average is equal to L1 plus L2 plus and so on up to Lm divided by m. But in wire A, all the conductors are connected in parallel. The total inductance of conductor A is given by L average upon m. Since all the m number of conductors in wire A are connected in parallel, the inductance of wire A is LA equal to L average upon M, that is L1 plus L2 plus and so on up to Lm upon m square. Now we can write LA using L1, L2 and so on up to Lm as making use of laws of logarithms. You just simplify it, you will get the result as I write here, 2 into 10 raised to minus 7 ln of m into nth root of d1a, d1b and so on up to d1n, d2a into d2b and so on up to d2n into d3a into d3b and so on up to d3n dash 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 into dma into dmb dash 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 up to dmn. So this entire product is under the root. Divided by m square root of d11 into d12 dash 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 up to d1m into d21 into d22 into dash 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 up to d2m dash 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 up to dm1 into dm2 into dash 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 up to dmm. Whole bracket ln is here, please remember that. What is this? This is now inductance of wire A, where d11 d22 up to dmm represent the 0.7788 times the radius of conductors one, two, dash 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 up to m respectively. The numerator of argument of natural log that is mnth root of the products of the mn distances between m conductors of wire A and n conductors of wire B is called geometric mean distance GMD, often called, that means this is also called mutual GMD and denoted by dm. The denominator of argument of natural log which is the m squared root of m square distances. That is the distances of the various conductors from one conductor and the radius of the same conductor is called geometric mean radius. It is abbreviated as GMR, also called as self GMD. And denoted by ds. Then that is, now we will make use of notations dm and ds in the expression for LA. LA is equal to 2 into 10 raised to minus 7 ln of dm upon ds. Unit is Henry per meter. Let us call this as equation now 17. To differentiate between inductance of wire A and wire B, we will write here SA. Inductance of wire B can also be obtained as LB equal to 2 into 10 raised to minus 7 ln of dm upon dsB, Henry per meter. The total inductance of a single phase two wire system may be now found as the total inductance of composite conductors of both wires will be L equal to LA plus LB equal to 2 into 10 raised to minus 7 ln of, using laws of exponents we can write here, dm into dm upon dsa into dsb Henry per meter. If the wires A and B are identical, then DSA will be equal to DSB. This substitution we will have to make here to calculate total inductance of composite conductors.